Hello, panel of judges. My name is Basin Evaluation. I'm an undergraduate student of the Department of Geology at Akwa University. I'm here to give a presentation on the Basin Evaluation of XYZ view over 5,000 Southeast Nigeria Delta. These are my team members, faculty advisor, and industry-based mentor. This is the outline which we follow for our presentation. Introduction. The aim of this research is to integrate 3D setting data and available well-log data from the XYZ field for a basin assessment to determine potential leads and prospects for the OML 5000 Southeast Nigeria. This is the workflow we adopted for carrying out the basic assessment of this area. The study area of the OML 5000 is located in Southeastern Nigeria Basin. It's about 15 kilometers from the shoreline and about 10 meters of average water depth. The exploration began in 1994 with the acquisition of 3D seismic data, and the acquired seismic data was processed in 1996, while drilling campaign began in 2002. Regional geology. The regional geology we consider under the topic of tectonic evolution. The tectonic evolution of the Nigeria Basin began with the rifting of the South American continent from the African continent, followed by regional subsidence which brought about the influx of sediments into the basin. And this is a geographic framework showing the geographic evolution of the Nigeria Basin, starting from the evolution of the Akwa Formation to the evolution of the Akwa Formation, then the Benin Formation. And the evolution, as I mentioned earlier, we have the evolution of deep marine fishes, followed by the subsequent and accompanying the evolution of clastics, which is the Akwa Formation, and followed by the position of the Biafra member, which is a reservoir rock, and before an unconformity cut across the study area, before the study area experienced the growth of shell diaparism due to the overburden. And the core member was developed being or seal rock or cap rock, while the continental deposits of the Benin Formation started depositing between the Pleistocene and Triassic. This is the stratigraphic framework of the Nigeria Basin adopted from Richard's in 1997. It shows the people belts contained in the Nigeria Basin, and our study area is within the offshore people belt. This is a play concept map of the Nigeria Basin showing our play elements, which include our shell rock, which is our source rock, and the Biafra sands, which is our reservoir rock, and the required shell being our cap rock. And it also shows numerous faults traveling across the field, which act as entrapments and closures for the hydrocarbon. Datasets. The dataset that we provided dynamic for the evaluation process included 3D seismic data, well-log data, pressure data, deviation data, core photographs, and gesture data. We integrated this data in order to produce time-based maps, volumetric analysis, and drill recommendations. The seismic data was provided was about 369 square kilometers in total area coverage, and the time range ranged from 0 to 5,000 milliseconds. We carried out the quality assessment and quality check on assessment data, and we were able to discover that there were A1 and A2X after our seismic coverage, and we also realized assessment data in order to improve its quality, and also enhance its identification and interpretation. This is our wells, and the number of wells that were given to us was 17, and only 21 wireline logs were given. 15 wells had deviation data, and only one well came with check with core photographs, which is well A3XZ, and well B1 and well A3X were the only wells that came with check shot data. We also carried out a QA QC for our database for the wells, and we were able to see that our well A3XZ didn't have hydrologic log, so we could now relate our core photographs and integrate it into our well. We also found that 10 or 11 of our wells did not have hydrologic log in order to relate our pressure data for fluid discrimination. The two-way travel time appears to also be shallow, so we needed to carry out the synthetic seismic program. This is the synthetic seismic program we should carry out. We employed two methods: the ball shape method and the final synthesis method, which is the stretch and squeeze method. We also plotted our depth against our two-way travel time in order to finally arrive at this equation using the second order polynomial. Seismic interpretation. After panning through our seismic data, we were able to find out that most of the area in the Southern Nigeria Basin had occurrence of shell diapers, and this was in conformity with the regional geology of the area. And these are identified as low velocity corrective to inflation-free layers. We are also able to identify that our wells were drilled in the microstructure, that is our well A1, A58 down to well A8, and well B1 structure was actually drilled into a graben structure. What's the conclusion? We carried out the fault integration and available seismic data, and we were able to arrive at a coincide fault integration for the whole seismic data. This is how the first framework looks like for the entire seismic data. This is a generalized fault framework of our study area. We displayed our wells on the seismic, and we found that our wells were clustered at the southeast portion of the study area. We also zoomed into our area of interest and interpreted the faults around the area of interest, and this is what we arrived at. I'll hand over the well analysis to my team member, that part. Thank you.
I'm Godwin Emmanuel. I'll be talking on the well log analysis and petrophysics. Well correlation. The reservoir was correlated across. We took a straight line running from the west to east. The reservoir sandstone was deposited in a high-energy deltaic environment and underlain by a thick Akata formation. The Biafra Reservoir, the delineated Biafra Reservoir, which composed of P0.5 reservoir and P1 reservoir on our well log, of which we correlated to our stratigraphic framework. The Ibom seal, which happens to be our regional seal, was being delineated on our well log and correlated with our stratigraphic framework. The sequence stratigraphy. The sequence stratigraphy, we used a depositional sequence model to get our sequence stratigraphy, which is composed of two sequences. And the P0.5 reservoir, the P1 reservoir, and the ABC reservoir were found in the Biafra sand. The P1 reservoir and the P0.5 reservoir were found in our low stance system chart. Reservoir ABC was being truncated by the Ibom unconformity. This is the pressure data which helps us identify our reservoir, that is the reservoir P0.5, P1, and also helps in fluid discrimination. The fluid discrimination of well 8X, we plotted our pressure against our depth, of which we got our gas oil contact of about 3,360 feet, which correlated with our well log. We also did the same thing for our reservoir P1, where we plotted our pressure against our depth and got our oil water contact at 3,649 feet, and we correlated it with our well log, and it fits in on our log. The petrophysical analysis. This was the method used in order to get our porosity, our water saturation, which we use the Archie's clean sand model, and our net gross. This is the result. The page thickness. The reservoir were correlated, and we got our page thickness for the gas as well as the oil. The stratigraphic interpretation. On our seismic, we were able to delineate our unconformity, which happened to be our Ibom angular unconformity. We also delineated our maximum flooding surface and our sequence boundary on the seismic. The Ibom unconformity surface, which happens to be the sequence boundary, was delineated on our seismic, where we took a straight line running from A to A prime. We got our sequence boundary, which happened to be in a hostile area. And this hostile area, our wells tend to cluster around that hostile area, which points to the fact that it's a prospective area. At this point, I want to hand over to my colleague, Mr. Ikefre.
My name is Ikefre Ayanime, and I will be talking on horizon interpretation and prospect identification. This is our map horizon on the seismic section for reservoir P0.5 and reservoir P1. This is our time map generated from the map horizon and our fault polygon displayed on it. And you can see that our boundary fault is trending in the northeast-southwest direction. And we also have another fault trending in the northwest-southeast direction. This is our zoom time map for reservoir P0.5 and P1, identifying our prospects. And on our prospect, we identify 8 prospects along the seismic section, and they were of good fault closure. This is our depth map for reservoir P0.5, and this is where the B1 penetrated in the reservoir and found hydrocarbon. This is where the A5X penetrated and found hydrocarbon. And these are our prospects on the map with good fault closure, showing a two-way closure. This is our P1 map, and this is our A5X structure and our B1 structure and our prospects on the map. This is our amplitude extraction with direct hydrocarbon indicator analysis, and there is our B1 structure, showing that amplitude conforms with the structure with corresponding to presence of hydrocarbon. In our P1, you can see that the amplitude here shows that there is a prospect there. Risk assessment. From our identified prospect, we were able to carry out a risk assessment for them, and computing all our plays, we were able to give a play success of 80% for our prospect. Volumetric estimation. This is the methodology in which we use in calculating the volumetrics, and this is how we got our gross rock volume, plotting the area with the depth. Volumetric estimation for reservoir P0.5. On our B1 structure, we were able to calculate up to a volume of approximately 500 million barrels, and our oil for the B1 structure was about 1 million barrels. And in our F5X structure, our gas volume was about 700 million barrels, and our oil volume was about 1 million barrels. Volumetric estimation for reservoir P1. On the reservoir P1, the B1 structure did not find gas, it's only oil that was there. So the volume we calculated for it was about 1 million barrels, and the P1 A5X structure found about 8 million barrels of oil and 1 million barrels of gas. Summary and conclusion. In the conclusion, we were able to identify that the hydrocarbon present in this field is gas and oil, and we have one play in the study area, which occurs in the upper Miocene, our Biafra sands, and our trap style include 4 closure and stratigraphic traps, which are the regional unconformity and our shell depth. And with 8 prospects we identified, all occurring in the upper Miocene, Biafra member. All key petroleum elements are present in the identified prospect, and the local structure is fault closure. Our recommendation for our identified prospect is that the well database should further be ascertained our recommendation for our identified prospect was that we further ascertain the presence of and volume of hydrocarbon in the identified prospect with an expanded database. Acknowledgement. We wish to thank NAPI for giving the students this platform to build capacity through this competition. And we are also grateful to Exxon Mobil and Slot Project for providing us with the workstation and the software. So our head of department and staff of geology at Akwa State University, we say thank you. And our industry-based mentor who gave us the technical assistance, we appreciate you, sir. Thank you.